Hello, this is how to contribute to the KDE community using Valgrind. Valgrind is a command line tool that you use to run other command lines. Let's see how we got to this page from the KDE homepage, kde.org. In the top menu, Get Involved. Scroll to Development. At the very end of the page says Debugging, and then Valgrind. So Valgrind is a tool. I'm using the Linux operating system Ubuntu 25.10. Let's make sure that Valgrind is installed. It's already installed. Thank you for subscribing and helping this YouTube channel. Now we're going to build a KDE graphical user interface application. We're going to build KCalc using the KDE build framework, which is called KDE Builder. Let's make sure that KDE Builder is up to date. KDE-builder -self-update. It's up to date. Let's build KCalc. KDE-builder space KCalc is going to build the KDE Git repository KCalc and all of its dependencies, all of the other KDE Git repositories that are needed when running KCalc. So 29 Git repositories in total. It does incremental build, not a full rebuild. Okay, so KCalc has been built. Let's run it. And make sure that it was built correctly. We have two ways of running KCalc, either using the command line KDE-builder space --run and then KCalc, or we can source a bash file. KDE build and KCalc, the name of the KDE Git repository, and prefix.sh. And then we run KCalc. Okay. We have built the KDE Git repository KCalc. There's an executable KCalc. We can see its full path. And we're going to use this command line instead of this command line. So we're going to just exercise Valgrind with the command line being KCalc. Let's start small and then we'll increment the Valgrind command line. It says that memcheck, which is a tool of Valgrind, is being used right now. So probably this command line part is not really needed. --tool equals memcheck. Maybe memcheck is the default tool that's used by Valgrind. We're waiting for the KCalc application to finish starting. So Valgrind is running the KCalc application. It's wrapping the KCalc process, similar to GDB, the GNU debugger, similar to a virtual machine, an emulator. And what it does is it intercepts some exported functions. And using those, we'll determine if there's a memory leak, if there's an uninitialized memory allocated that then is being used, and other memory errors. Double free, if you allocate 5 bytes and then you use 6 bytes. So it finds immediately an issue with write v. says that there's uninitialized bytes in the parameter, which is vector of 0. I'm not sure where write v is. It says it's a syscall, so it's probably from the interface between the Linux kernel mode and the user space. And then says libxcb, which is the x11 library. And then that's being used in the part of the Qt framework that interfaces with the x11 libraries, so QXCB connection. I'm not sure if this is an issue, but even if it is an issue, the issue is probably inside XCB or maybe inside Qt, but this is down the stack. I wouldn't really like to do a git commit towards the x11 libraries or towards the Qt framework. Okay. Unfortunately, we're not really sure when one issue starts and when the next issue starts. So there's just this label here, which is the process ID of the kcalc process. I would like if I also have the timestamp, because all of these lines that are part of the first issue that was encountered will have timestamps really similar. Whereas this one, maybe it's a different issue. So this is in AES hash 128, whereas this one is in libxcb. So I'm going to guess that these two issues are different. Let's ask Valgrind to also display timestamps, and that will make it really visible and separate the different issues. Let's exit. We can stop Valgrind using Ctrl+C, or we could close the kcalc application, the application that's monitored by Valgrind. Let's go with Ctrl+C. Okay, let's look at the command line parameters of Valgrind. There's a ton of help here. Let's put the text that was written to the console in a plain text file. Let's open in Kate. Let's search for timestamp or time or date. So I can see the command line parameter is timestamp equals CS probably. Let's prepare a command line. The previous command line was Valgrind kcalc. And this thing probably needs to go in the middle, and the command line should be the final parameter. Okay, let's see the difference. And now we have timestamps. Timestamp in milliseconds till the moment that the process has started. Yeah, that's one way of displaying timestamps. Either you show milliseconds in UTC, so the current hour, or you display the number of milliseconds till the process has started. Okay, so in here we started the command line, and let's see if now we can easily separate the various issues encountered by Valgrind. So at millisecond 8 to 9 is the entire issue with syscall write v. At millisecond 126 is the issue with AES hash 128, 126 ends here. And then there's another issue at millisecond 988, where it says conditional jump or move depends on uninitialized values. And then the entire call stack is in kcalc code, so in a single KDE Git repository. Let's see what this issue is about. So we have a call stack. Let's copy it into a plain text file. And let's open this application, kcalc the source code in Qt Creator, the integrated development environment from the Qt framework. And let's go through the various addresses. So source code file name and line number. Let's find the file that we need to open in Qt Creator. So that's tilde/kd/build, kcalc, and then the cmake cache.txt file. Let's copy the full path, Ctrl-Alt-C. Open Qt Creator, file, open file or project, Ctrl-V, open. And because it's not really using QML that much, we don't need to do anything else. CMake configure will work correctly, building will work correctly, running and debugging. Everything will work correctly, even though we only opened Qt Creator and loaded the cmake cache.txt file inside. Let's look at the call stack. So it says in kcalc.cpp the entry point, the main function. Let's see how we do that. File. Okay, so the file name colon line number is the syntax for the search bar in Qt Creator. Okay, so line 3005 is the main part of the main function. So the main free function C++ is the entry point of the executable. It configures theming, the about box, the command line parser, and then creates the main object, which is kcalculator, which is a graphical user interface application, uses the KXML GUI KDE framework. Okay, and then it says that inside the constructor that has a parameter QWidget, which is just one constructor, this guy, at line 1 to 4, 1 to 4, this guy, update display. So this is a method. At line 2351, at this place, another method called slot clear result. And in here, line 1474, another method call slot clear base mode amount. And we're getting close. Line 2067 is the if block, the condition inside the if. And that's it. Says that conditional jump or move depends on uninitialized values. So in this line, there might be uninitialized values. If such a thing exists, We probably can see it if we're going to run the source code in the debugger. Let's build. Compiler output says that nothing needs to be built. It's an incremental build. It's a very similar build to what KDE-builder does. And then we can just start debugging of startup project. Okay, so we have breakpoints everywhere. We can go step over. Let's see the shortcut for step over, F10. And we're at the place. So line 2067 in kcalc.cpp. Let's see what this thing is. Success single number is an enum member. So I guess that it has a value. Probably the value is the integer 1, and this would be 0. So maybe this other thing is not initialized. Parsing result. So it's value 0 success. Let's run it again and see if we get the same value here. We are using the CMake build configuration debug, which might be different from the default CMake build configuration, which is rel with debinfo, as it concerns the way private object members, class members are being initialized, the fields. It's still 0. Okay. Let's see where parsing result is initialized. So there's two parsing results. One is in kcalc_parser, and the other one is in kcalc. In kcalc_parser, in the private fields area of the class declaration, line 53. Parsing result is being initialized to the value empty, whereas in the other class, in kcalc class, inside the private area of the kcalc.h declaration, the parsing result private field of the class is not being initialized. So in here we're reading from parsing result, reading, writing, reading, and in here we're not initializing it. So probably we'll need to also initialize when we declare parsing result in here. Let's just prove that this line is not being run. 2405. F10. So indeed we got to line 2065 where we try to read from parsing result before parsing result is populated in the method commit input. So that's probably the reason. So in here we'll need to assign it a value. I'm not sure which value. Let's see if empty is okay. So it's an enum, default is value 0 success, then there's a success single number, empty, and invalid token. Let's see how which with which values is it compared. So when we read from parsing result, we compare it with single success single number twice. We compare it to empty and to invalid token. So I guess if we initialize it to empty, we'll not introduce any bugs. Okay. I didn't even compile the source code, and the integrated development environment Qt Creator says that we're not going to be able to see the symbol empty. So let's see if we fully qualify it. Okay. This would be it. Let's look at the git commit and build and see if we have fixed the issue. There's a terminal available in Qt Creator. We could, and it's the current directory is where we would expect, which is the directory where we git clone this KDE git repository. It's a git repository. Let's use the graphical user interface tool git GUI from the git project. Let's make sure that we're using the latest and greatest. So remote fetch from origin, repository visualize all branch history, says that the local git master branch and the remote origin master branch point to the same git commit. Okay, let's actually do a git commit. Where, what did we do? Initialize this thing. Why did we do this? We are trying to fix a Valgrind issue. And the issue is this thing. We can do this commit and we can then amend the commit. So let's do the commit. Even if we're going to just ignore this git commit, we can just do it in order not to lose work and look easier at the differences. Okay, so the change looks okay. We have the console terminal emulator. In here, we can build kcalc again. If we're going to run the command line kd-builder kcalc, it's going to try to build incrementally all of its dependencies, which we don't really want. So no include dependencies. We also don't want KDE-builder to do git operations. We're in a branch, so I'm not sure if KDE-builder will revert our git commit, but just to be extra safe, I'm going to use this command line -- no src. And let's do a deep build. So a complete rebuild, not an incremental build. KDE builder, the name of the module, kcalc, no src, no include dependencies, refresh build. Let's actually close the kcalc executable that we had running in Valgrind in console in the second tab. Okay, so kcalc did build successfully. We didn't actually look in depth. There's a KDE builder command line parameter which is called -- debug that shows way more text in the output of KDE Builder, including the progress of the Ninja install step and the Ninja build step. Okay, we're going to run Valgrind again with to make sure that the error, the issue has disappeared. But still, we can see at the end of the output from the previous run of Valgrind that Valgrind would like to communicate more things to us. So let's fix that. So Valgrind suggests that we append command line parameters --leak -check equals full and --track -origins equals yes. Okay, so the first issue encountered by Valgrind is the one with syscall write v. And then there was our issue, and then the application kcalc was displayed. Okay, first issue at millisecond 292, and then there's the issue with AES hash at second 606, and then that's it, no other issue. So we have successfully fixed our issue. Okay, let's actually put the command line in the git commit message. So we go amend last commit, Control V. So the git commit message has the correct title, which is where and what, and then there's the body of the git commit message with additional details. So why we did this? What we did it because a tool told us to do it. What tool? Valgrind. What's the command line of the tool? This guy. What was the output from the command line tool? This one. The lines are a bit too long for a git commit message body, so that the git commit message body lines should be no longer than 80 characters. But we'll keep them as they are. Commit. Let's look at the history from Git GUI main menu repository visualize all branch history. We're going to actually do a GitLab merge request. So right click on the git commit, create new branch with the correct branch name. This string is okay. Check out the branch. So work and MariSP initialize and parsing result. A final look at the git commit. So correct message and the correct fix. Let's push this git commit. Remote, push, cancel. What did you do? We didn't press the rescan button. Remote, push, and push. Okay, and it says that we can create a merge request either by following this URL or if we just navigate to the kcalc Git repository. Close. I have searched for the GitLab project for KDE invent kcalc. It found the correct place. And GitLab asks me if I want to create a merge request, which I do. Let's see what it says in here. From the correct branch towards master branch, the correct title, the description always gets messed up because GitLab has decided to ignore new lines, which is a bug in my opinion. Let's see how we do this. Yeah, something like that. Delete source branch, don't squash commits, changes. There should be just one line changed, correct, and just one git commit, correct. This is it. We're going to create the merge request. At the end of the previous run of Valgrind, it now suggests that we add an additional command line parameter, show leak kinds all. So let's improve the command line even further. Like this. Let's see the difference in reporting that Valgrind shows between the first version of the command line, the Valgrind ---- timestamp yes kcalc, and this full line for the issue that we have just fixed. Let's go back in time using Git, check out the master branch, move the master branch here. Before we did the git commit. And let's run with with just this command line. We need to build first. So timestamp yes, leak check full, track origin yes, show leak kinds all, and then the command line. We have the previous report error, which looked like this. Let's see if we get more details. This is what we get now, so the millisecond to 1.5. Let's compare them side by side. The simpler version and the more complete version. So additionally, it says that we're doing a heap, not a stack allocation. We're using C++ operator new. We can see how Valgrind operates by replacing malloc, the exported symbol, from the shared library probably. But we already knew the line in main, which is the same one as this one. And we can see English UK instead of English US with an S uninitialized instead of a Z. And here another occurrence. So in the process kcalc, I couldn't really find issues in the KDE source code. I could find issues in 5 places in the Qt source code, including with qstring plus operator, some places around realloc, where it reallocates a member field, private member of a class that is not initialized. I have switched to another KDE graphical user interface application, Arc. So I have built it using KDE Builder. And I have changed the Valgrind command line. Now it has the command line parameter -show -leak -kinds definite instead of all, because I do not want it to show me probable possible memory leaks. I want it to show me the ones that are for sure memory leaks. So less noise, but still Valgrind identifies hundreds of issues when running an executable. So let's have the minimum possible amount of issues, the ones that are as certain as possible, and let's fix from those first. And I'm redirecting both the standard output and standard input, standard output and standard error, piping it to the T command line, which will both write to the terminal and then rewrite to this plaintext file tilde/valgrind_out.txt, which then I have opened in Kate. Okay, this is the Arc process that has started running this command line. I didn't click anything on inside Arc. I'm looking at the output. So the same syscall write v, the same AES hash 128. Maybe these issues can be fixed. Maybe these issues at least can be silenced in a way. Both tell me that the people that work on the Qt frameworks don't regularly use Valgrind on the source code to at least fix the simple low-hanging fruit, such as uninitialized fields, to reduce the number of issues that Valgrind finds in Qt framework source code. Because if the number of issues that are easily found by Valgrind inside Qt framework source code shrinks a lot, then that makes the lives of people that use the Qt framework way, way easier. If you're running your application that uses Qt under Valgrind, you should find most of the issues in your code, not in the code from third-party libraries, from Qt framework or from places even lower than that, such as X libraries or graphical GPU drivers. Okay, so that was issue at millisecond 865. Next up, issue at millisecond 905. It's of type realloc inside the Qt source code. Let's actually see this. So we'll want to open using Qt Creator, the project Arc. So let's do that. tilde/kd/build arc cmake cache, Ctrl+Alt+C, file, close all projects and editors, file, open, file or project, Ctrl+V, enter. Configure project. cmake configure step runs automatically. Nothing to build. Okay. So let's start from the beginning at millisecond 905. Let's actually copy this part out. Okay. Let's go straight to this place if we can. KUIT formatter private. Where is this one? What about key localized? What about this guy? So I'm going to find this file klocalized string.cpp. I kind of know how to go get there. So by navigating to the symbol internationalization I18N, goes to klocalized string.h, and we're going to need to go to the file with the extension .cpp, so klocalized string.cpp. And we can get there, for instance, by entering with the debugger inside the I internationalization function, so inside the body of this symbol. Start debugging. And we're going to step inside and then look at the call stack. If it says klocalized string, we're in the correct place. Otherwise, we go this step out, shift F11. A million of times. So I didn't manage to step into the correct place. I searched for the klocalized string.cpp file in the ~kd/src directory. I found it in the module k internationalization ki18n, subdirectory src internationalization klocalized string. I have copied the full path of the file, Ctrl-Alt-C, and I have opened the file. Let's do it again, Ctrl-C, Ctrl-O usually, Ctrl-V. And then we navigate to this place, line 602, and put a breakpoint there. And now we can start the Arc application. And it stops before doing much. Let's close some of these tabs. Okay, so we're now in the correct place. So klocalized string.cpp line 602 is going to come up. I have a breakpoint there. It says final translation, format markup, which we can see in here, and then it's going to enter the class KUIT formatter. So let's go to line 602. Okay. So it enters the method toString, but it doesn't get to the place where, to the line 602. this identifier markup aware should be true. So the error was that while arc was running and it was being run by Qt Creator, not enough environment variables were set correctly. And this way the K part for arc could not be found. And in order to fix this, because we're using KDE Builder, we need to configure Qt Creator in a certain ways to make sure that when Qt Creator is running the application, it runs as well as possible. And that is being done by following the tutorial on how to load inside Qt Creator a project that you have built using KDE Builder. And what I do is I get the content of the file prefix.sh, expand it, and then those environment variable names equals value pairs. I paste them in projects, run settings, and environment, and then in this large multi-line edit box. This way, the process Arc is going to be able to find the Qt plugin paths, the QML import paths, etc. Okay, and now we have arrived at line 602, which is this. Okay, so we're in klocalized string private to string, and we need to enter format markup. So F11, F10, the debugger is jumping all over the place. We're using the CMake build configuration debug, yet still it's really hard to step into the correct method. Because F11 doesn't go into format markup, it goes into QString from UTF-8, into the various C++ operators that are being called here, etc., to compute the values of each of the arguments of the call to format markup. Okay. And format markup line 775 is this. And KUIT setup.cpp line 1645 is this guy. And KUIT setup.cpp line 1222 is this guy. And then to visual text. We're inside to visual text, and in here we need to go to line 1402. This thing. And this is the plus equals for a QString, which takes us to operator plus equals in QString of QChar. This thing. And that takes us to QString append. Let's see how we get there. I have pressed F11 step into. Yeah, so probably this operator plus equals of QString with parameter QChar is really, really popular. So don't put a breakpoint there. Probably this is the issue, that realloc has as first parameter a identifier that's actually a field private that wasn't initialized when declared. Just make that thing the equivalent of null or null PTR, and that will make realloc happy and Valgrind happy. Okay, so this is it. This is a important tool, Valgrind. It can be used to run various KDE graphical user interface applications, and not only. You can also run KDE command line applications, for instance. This is the command line that I'm using right now. So Valgrind timestamp equals yes, leak check full, track origin yes, show leak kinds definite, -s for summary command line, and then whatever Valgrind writes to the terminal should also land into this file. And then using Kate, I can watch the file valgrind_out.txt as it gets edited. There's buttons to do live refreshes, or I can just click on the button when new contents exist in this file. And then in order to see just one of the issues, I double click inside Kate on the millisecond, like this. And I can see with yellow all of the lines that are part of this issue. There are call stacks, there's file names, line numbers, all sorts of interesting information in here. So go over as many KDE applications as possible. In time, you will learn that some issues are inside the X libraries or in other places that are not part of the KDE community. If they're part of the Qt framework and they're easy to fix, it would be actually important to do a git commit towards the KDE framework, because that will have compounding effects on the applications that use the Qt framework. Will make lives easier for many, many people. So this was it. This was how to use Valgrind to contribute to the KDE community. Thank you.